Hey all, today we are actually going to solve and graph compound inequalities. So last time we had class, we did a parking lot activity where we just looked at when could you park, and we talked about two situations when it could be an or situation where the graphs would kind of be two different situations, or we talked about and situations where you had to be in between two endpoints. So today we're actually going to talk about it and solve a couple, and then you guys will solve a couple. So we're going to be on page 17 and 18 in our notes. So we'll go ahead and go there. All right. All right. So I'm going to go ahead and zoom in. Okay. So compound inequalities are just two inequalities or more that are joined together by the words and or the words or. So first we're going to do the word or. Okay, so the first type is the or, and that is when they have a tendency to be graphed away from each other. So when we did the parking lot activity, we could have done something like x is less than or equal to -2, or x is greater than 3. So we're just going to make sure we feel good with graphing them. So x is anything less than or equal to -2. So here's -2. I'm going to use a solid dot because it says less than or equal to. I'll shade to the left. Or it could be anything that is greater than 3. So here's 3. It can't actually be 3, so I'm using open dot, and then I will shade anything greater. Okay, so just making sure that we feel comfortable with when there is the word or, usually it is two that are going away from each other. Okay, so then we have two graphs, and we are going to just describe the set of numbers that are graphed, and we're going to write an inequality for it. So for this one, it says x is anything that is smaller or equal to -3. Or we have this second inequality that says x could be anything that is bigger than 2. Okay. So for the next example, we have two of them. So we have two different situations. So the first situation is anything x can be a solution that is less than or equal to -4. Or it can also be a solution for anything that is greater than or equal to -1. Okay, now we're actually going to start solving them. Now, again, solving isn't extremely hard. We just have to remember that if we multiply or divide by a negative number, we have to flip the inequality symbol. So the first problem, we have -3x is less than or equal to -9, or we have 5 plus x is less than 6. So we are just going to solve this like we normally do. We just have two different problems. So I need to first solve this one. So I'm going to divide by a -3. And because I divided by a -3, I'm going to flip the symbol. Okay, so I have x is anything greater than or equal to 3. Okay, or we have this other solution, so we're going to solve that one. So we have 5 plus x, so I'm going to subtract 5. Or x is anything less than 1. Okay, so there is my solution. And then if we were to graph the solution, we have 1 and 3. Okay, and it says x is anything greater than or equal to 3, or x can be anything less than 1. So x can be a lot of numbers. It's literally any number besides 1 through 3, but it could be 3. So x can be a lot of these values. All right, for the next one, we have -3 times the sum of 2x plus 1 is less than -15, or 1 minus x is greater than or equal to 5. So again, we're just going to solve this the way we know how to solve it. We just have two separate problems. So we're first going to distribute. -6x minus 3 is less than -15. Then I'm going to add 3. Then I'm going to divide by -6. Because I multiplied by a negative number, I'm going to flip the symbol, and I get x is greater than, I'm going to flip it from less than 2. Okay, then our other one, we have 1 minus x is greater than or equal to 5. So I'm first going to get rid of the 1. Then I'm going to divide by that negative or that negative 1. Because I divided by negative, again, I'm going to flip my symbol. So I have x is greater than 2 or x is less than or equal to negative 4. Okay. If I wanted to graph what this solution set would look like, I have a number line. I have negative 4, there's 0, 1, and 2. Okay. So for this solution, we have x is anything greater than 2, or x could be anything less than or equal to negative 4. So here is my solution, and here's the graph of my solution. Okay. Now on to page 18. This one we have the word and. Okay, so inequalities with the word and have a tendency to be graphed together. Okay, so I'm going to show you guys how we would graph this and see what we're talking about, and then we have a different way to write the words and, so we'll talk about that. So for this example, we have x is anything that is greater than negative 6, and at the same time, x is anything less than 1 or equal to 1. Okay, so first I'm going to just graph the first one. X is anything that is greater than or equal to negative 6. And at the same time, x is anything that is less than or equal to 1. Okay, so what the word and means is they have to apply to both of them. So while you could graph both of these on top of each other, the only true solution is anything between negative 6 and positive 1, and x is anything between those two values. So while these are nice to graph to visualize, really the solution is anything between negative 6 and positive 1 and anything between them. Okay, so when we rewrite inequalities that fall between two endpoints, they're usually written in a more condensed form because writing the word and, that just takes a lot of time. So for that example that we just had, x is anything greater than or negative 6 and less than or equal to negative 1, this is a more condensed version and how we could actually write this. Because when I visualize this, okay, we'll start with x right here. Okay, so x is anything, if I look to the left, greater than or equal to negative 6. And at the same time, when I read it to the right, x is anything less than or equal to 1. Okay? So when I read this and visualize this, I just like to see, okay, there's one endpoint, negative 6. Here's the other endpoint, positive 1, and x is in the middle of them. So I know to shade in the middle of them. Okay, so we'll do a couple of those because that's probably the new part from the parking lot activity. Okay, so for this problem, we have something graphed, and we are going to just write the solution set. So I look and I see that the shaded part is in between negative 4 and positive 1. It could be negative 4, but it can't be positive 1. So here are my two endpoints, okay, and x is in the middle, okay. When I compare negative 4, x is anything that is larger than negative 4. So when I think about if it's on the right-hand side, x is larger or equal to negative 4. When I compare it to 1, the shade is anything smaller than 1, so x is anything smaller than 1. And that is the solution. All right, for this next one, we have x is shaded in between negative 2 and 6. It can't be negative 2, but it could be 6. Okay, so here are my endpoints, negative 2, 6, and x is being shaded in the middle of them. Okay. When I think about negative 2, the shade is everything greater than, so x is anything greater than, but not equal to. And then when I compare 6, the shade is everything smaller than 6, but it could be 6 as well. So the way we'll read this is -2 is less than x, which is less than or equal to 6. We would read this one as -4 is less than or equal to x, which is less than 1. All right, so for the last two problems, we're going to solve an and inequality. These don't have the word and. I know that they are implying and because I see two symbols and basically like endpoints on either side. Okay, the cool thing about this one is this is basically just like having two separate equal signs basically. So we need to get rid of this +4. So when we subtract 4, we're just going to subtract 4 to every value on this side of this endpoint and this side of this endpoint. And when we do that, we get a 0 in the middle, which is what we wanted. So now x is by itself in the middle. Okay. Then we have to do 2 minus 4, which is -2, and 9 minus 4, which is 5. Now x is isolated in the middle, and we now have the two endpoints, -2, and 5. So here's -2. Here's +5. X is anything in the middle. Okay, so I'm going to shade in the middle because these are my endpoints. I'm going to put a solid dot at -2. I'm going to put an open dot at 5. And X is everything in the middle of those two endpoints. All right, for the final problem, we have -4 is less than or equal to 2 times x minus 6, which is less than or equal to 4. So first, our goal is again to isolate the variable. So we're first just going to distribute. Then I'm going to get rid of subtracting 6 by adding 6. I just have to remember to add 6 to every endpoint. Okay, so then that would make a 0. We would have 2 is less than or equal to 2x, which is less than or equal to 10. Then we would get rid of the 2 by dividing by a +2. We divided by a positive number, so we don't have to flip the symbols or anything like that. This would make x be isolated. We would have 1 is less than or equal to x, which is less than or equal to 5. Then if we were to visualize what this solution meant, here is 1 and here is 5. X could be 1, so we're using a closed dot, and x could be 5, so we'll use a closed dot as well. And x is in the middle of these endpoints, so we will shade in between. There's my cat. She says hi. All right. All right, so for today, guys, there is a Savas assignment. There will be 6 that are very similar to these where you're just matching a graph to the solution. And then there will be 6 more where you have to solve similar to these ones where it could be and or. All right, I'll see you guys tomorrow.